This is a short video presentation on two special cases when we're solving systems of equations. When solving systems of equations, sometimes we will have no solutions. Thus far, we've always had a solution, but sometimes we'll have a system with no solutions, and other times we will have two systems that have infinite solutions. So I want to look at these. And first, I'm going to take two equations, a system of equations. So let me write it out here. Y equals 2x minus 3. Y equals 2x minus 3. And 4 minus y. 4 minus y equals negative 2x. And we're going to solve this by substitution. So I see that my first equation here is already solved for y. I have y by itself. So I'm going to take 4 minus, I'm going to use parentheses for y, equals negative 2x. And then I'm going to substitute 2x minus 3. When I do that, I end up with, and this is like a 1 here, negative 1. And I distribute that, I have 4 minus 2x plus 3 equals negative 2x, or 7 minus 2x equals negative 2x. Now, I have x's on both sides, so I'll add 2x to both sides. And I have 7 on the left equals, these canceled, and these canceled, so I have 7 equals 0. 7 equals 0? Makes no sense, right? That's not true. That's a false statement. So we have no solution. If we get a false statement, obviously incorrect statement, it's no solution. Now what I want to do is look at y. We're going to draw the graph and look at exactly why is this happening. Okay, we have our graph here, so now let's graph these. The first equation right here, y equals 2x minus 3, is pretty simple to graph. Negative 3, well, we'll make Musket happy and put the scale here. Negative 3, 1, 2, 3. And we go up 2 over 1. And our line looks like that. So up 2 over 1, up 2 over 1, up 2 over 1. And we'll draw the line. Okay, that line is drawn. Now let's go to our second equation, which is this. I'm going to write it over here. I'm out of space. 4 minus y equals negative 2x. I'm going to subtract 4, subtract 4. Again, negative y equals negative 2x minus 4. And I multiply by negative 1 to both sides. Negative 1, negative 1. And a lot of you forget when you're multiplying to put parentheses here on the negative 1 or negative anything. If you don't, it's subtraction. So make sure you have parentheses there. Here it doesn't matter. So now I end up with y equals 2x plus 4. So 2, 3, 4, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And we see that our lines are what? They're parallel. I'm going to draw the other one. The lines are parallel. That means they don't intersect. That means there never will be a point of intersection, and that's why it's no solution. Okay? So, when we're graphing, and when the lines are parallel, or we get an obviously false statement, we have no solution. All right, let's look at two more equations. So y equals 2/3 x minus 2, y equals 2/3 x minus 2, and 2x minus 3y equals 6. Again, the first equation is solved for y, so I'm going to substitute it, even though it has fractions. So, 2x minus 3 times whatever y is equals 6. Y is 2/3 x minus 2. And now I distribute 2x minus, when I distribute this, the 3's cancel. 2x plus 6 equals 6. 2x minus 2x, those cancel out, and I get 6 equals 6. This is a true statement. When I get a true statement like this, we have infinite solutions. Infinite solutions. So if we look at graphing, we should have a case where the graphs intersect in an infinite number of spots. All right, let me draw the graph just a moment. Okay. All right, let's graph the first line now. So y equals 2/3 minus 2. My y-intercept is here. That's 1 and 1. And I go up 2 over 3, up 2 over 3. My graph looks like this, down 2 over 3. And I'm going to draw the line. All right, there's our first line using slope-intercept. And this line right here, this equation here, I'm going to use xy intercepts. So when x is 0, y is negative 2, and when y is 0, x equals 3. So when y is negative 2 is this point right here, when x is 3 is this point right here, if I draw my line, I'm drawing the same line. It's exactly the same line. It's intersecting in an infinite number of spots. Hence, we have infinite solutions. All right, quickly review. If when we're solving, we get a false statement, there's no solution. If you're graphing it and they don't intersect, there's no solution. When we're solving a system of equations and we get an obviously true statement, 6 equals 6, a definite true statement, no variables left, we have infinite solutions. Or when you're graphing them and they're the exact same graph, infinite solutions. We don't intersect, no solution. Same line, infinite. We have no variable here, false statement, no solution, no variable, true statement, infinite solutions. All right, I hope this helps and have a great day.